Hello everyone. Today we discuss a problem on simple linear regression. How to form the regression lines. It's already discussed the formulas. Okay. Now we discuss a problem on regression lines. Regression line of y on x and regression line of x on y. Here I am taking the observations x. Observations are 12, 9, 14, 11, 12, 8 and y observations are 18, 16, 20, 19, 20, 15. Okay, here these are here the observations for x and y. Now we form the regression line for x, regression line of y on x and regression line of x on y. Okay, regression line of y on x is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Okay, so for this for finding the regression line, first we have to find x bar and y bar and small r, that is the coefficient of correlation, and sigma x sigma y are the standard deviations of x and y. Okay, so first we have to calculate those values. After calculating the values, and then substitute those values in this regression line. Okay, how to find x bar and y bar first. Here x bar is the mean value of x. Okay, here we have 6 observations for x. Okay, the mean value of x is given by sum of the values by sum of the observations by number of observations. Here we add all these values, we get 66 divided by 6, that is 11. Okay, here the mean value of x is 11. Next we have to find the mean value of y, that is denoted by y bar. Okay, y bar is equal to summation of yi by n. Okay, sum of all the observations of y divided by number of observations. Here we are adding all these observations, we get 108 divided by 6, we get 18. Okay. After that, for finding the coefficient of correlation small r, we have some of the coefficient of correlation formula is summation of xi minus x bar into yi minus y bar by square root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. Okay, for finding the coefficient of correlation, we have to find xi minus x bar terms, yi minus y bar terms, and xi minus x bar whole square and yi minus y bar whole square values. Okay, the summation of those values we have to calculate. Okay, for this we form a table for this based on the given observations. Okay, here xi means the observations for x are denoted by xi. Okay, we denoted the values at 12, 9, 14, 11, 12, 8. Xi minus x bar. Next we have to calculate xi minus x bar. That means we subtract x bar from each of these x observations. Okay, here x bar value is 11. So subtract 11 from these 6 observations. 12 minus 11, 1. 9 minus 11, minus 2. 14 minus 11, 3. 11 minus 11, 0. 12 minus 11, 1. 8 minus 11, that is minus 3. Next, square of these values. 1 square 1, minus 2 whole square is 4, 3 square is 9, 0 square is 0, 1 square is 1, minus 3 whole square is 9. Okay. Now add all these values. xi minus x bar whole square values. Okay, we add all these values, we get summation of xi minus x bar whole square. Okay, we get 24. Next, take the y observations. Y observations are denoted as yi. Okay, 18, 16, 20, 19, 20, 15. Okay, now we have to calculate yi minus y bar. That means we subtract y bar from yi values. What is the value of y bar here? 18. So we subtract 18 from each of the observations of y. Okay, 18 minus 18, 0. 16 minus 18, minus 2. 20 minus 18, 2. 19 minus 18, 1. 20 minus 18, 2. 15 minus 18, minus 3. Next, square of the values. 0 square 0. Minus 2 whole square 4, 2 square 4, 1 square 1, 2 square 4, minus 3 whole square is 9. Now add all these values, we get 22. Next we have to calculate xi minus x bar into yi minus y bar. That means we multiply these two columns, corresponding elements of these two columns. Okay, 1 into 0, 0. Minus 2 into minus 2, plus 4. 3 into 2, 6. 0 into 1, 0. 1 into 2, 2. Minus 3 into minus 3, plus 9. Now add all these values, we get 21. So summation of xi minus x bar into ya minus y bar is 21. Okay. Now we have to substitute all these values in the coefficient of correlation formula. So summation of xi minus x bar into ya minus y bar value is 21. Okay, 21 divided by square root of summation of xi minus x bar whole square is 24 and summation of ya minus y bar whole square is 22. 21 by root of 24 into 22. Now we simplify this value, we get 0.9139. Okay. So for getting regression line, we have to find additionally sigma x and sigma y. Those are the standard deviations of x and y. Okay, first we have to calculate sigma x square. Sigma x square is equal to summation of xi minus x bar whole square by n. Okay, first we have to find the variance sigma x square. After that we find the standard deviation sigma x. Okay, the variance formula sigma x square. For x observations, we have to find the variance. So the formula for this is summation of xi minus x bar whole square divided by n. Already we calculated summation of xi minus x bar whole square, that is 24. 24 by the given number of observations are 6. 24 by 6 is 4. Okay, so sigma x is equal to root 4, that is 2. Okay, next sigma y square. Sigma y square, that means the variance for the y values. Okay, then based on the y observations, we have to find the variance. Sigma y square equal to summation of ya minus y bar whole square by n. Here already we calculated summation of ya minus y bar whole square, that is 22. 22 by number of observations are 6. So we get 3.666 continued. So we shift the decimals to 4 places. So 3.6667. Okay, so from this sigma y is equal to square root of 22 by 6, that is 1. Square root of 3.6667 or 22 by 6. So that is 1.9148. Okay. Now we form the regression lines. Okay. The regression line of y on x is y minus y bar equal to r into sigma y by sigma x into x minus x bar. Okay. Now we substitute all the calculated values. Okay, yx bar, y bar, r, sigma y, sigma x. We have to substitute all the values. We get a regression line. Okay, y minus, here y bar is 18 is equal to r. R is the coefficient of correlation. That value is 0.9139. 0.9139 into sigma y, that is standard deviation of y, that is 1.9148 divided by sigma x. Sigma x is 2. Okay, divided by 2 into x minus x bar is 11. Okay. So first we simplify this value, this coefficient value or slope of the regression line. Okay, 0.9139 into 1.9148 divided by 2, we get 0.8749. That is the slope of the regression line. That is also called the regression coefficient. Okay. After that, we multiply the x minus 11 with 0.8749. Okay, 0.8749 into x minus 0.8749 into 11, we get 9.6239. Okay, so from this we have to find y. That means we convert minus 18 to right side, we get plus 18. Okay, now simplify these two constant values. 18 minus 9.6239, that is 8.3761. So this is equal to y is equal to 0.8749 into x plus 8.3761. This is the regression line of y on x. Here y is dependent on x. Okay, here the regression coefficient is 0.8749. Okay, this is the regression line of y on x. Next, regression line of x on y. In the same way, the regression line of x on y is x minus x bar is equal to r into sigma x by sigma y into y minus y bar. So substitute x bar, y bar, r, sigma x, sigma y values in that. So x minus 11 is x minus x bar value is 11 is equal to r value 0.9139, sigma x is 2, sigma y is 1.9148 into y minus y bar is 18. Okay, here also first we have to simplify the r into sigma x by sigma y term. Okay, that is the slope of the regression line. Okay. We simplify this term, that we get 0.9545 into y minus 18. After that we multiply y minus 18 with 0.9545. 0.9545 into y minus 0.9545 into 18 is minus 17.1810. Okay. So from this we have to calculate x. That means we convert minus 11 to right side. We get plus 11. Now simplify these two constant. Minus 17.18 plus 11. 181 plus 11. What is minus 6.181. So this is x is equal to, this is of the form x is equal to m2 into y plus c2. Here this is the regression coefficient. This is the regression coefficient dxy. This is the regression line of x on y. Here the slope is dxy. Here this is the regression line of x on y on x. So here this slope is called regression coefficient of y on x and it is denoted as dyx. Okay, this is it. This is the calculation of the regression lines y on x and x on y. Based on the regression lines, we have to find the regression coefficients also dxy and dyx. Okay. Okay, thank you.